So, we're going to look at two rational functions again today. The first one will not have a slant asymptote, okay, just to kind of, but it'll be kind of like more, I don't know, it'll be different looking than the ones we've been doing so far, okay? It's a little more tricky in that sense. We'll talk about slant asymptotes, and then we'll do a question with the slant asymptote, okay? So, yeah, all right, I'm going to kind of try and roll here a little bit. So if I'm going too fast, just let me know, but we'll see how it goes here, okay? So, just jump right here. We're going to graph f of x equal to 3x squared over x squared minus 4. Okay. So remember, right, what we're going to do from this point is we're going to find the domain from the, and really in that we're finding the domain restrictions. From those domain restrictions, we're going to classify them either as a vertical asymptote or whole. We'll also find zeros. We'll also find horizontal asymptotes, and then we'll find any additional points we need, and finally we'll graph it. Okay. So Jeff, question, yes.
That equation is 3x squared over 3 cubed minus 4.
It's
right?
3x squared over x squared minus 4. Yes.
X squared.
X squared minus 4. Yep.
X squared, not x cubed.
Correct. X squared. Yep. And I'll zoom in here some more if that helps. Does this help with something, Jeff?
Yes, that does help.
Okay. All right. So the domain for this function. All right. That's the first thing we're going to find here. All right. So again, we're looking for domain restrictions. Could we potentially take the square root of a negative in this case?
Yeah, at 2.
So is there? But in the function, are there square roots?
No. At 2, there's a domain restriction.
Okay, but answer my question though. I didn't ask that question. I asked, hey, can we take the square root here? No, right, okay. Could we divide by 0 though? Yes, okay, there we go. So
that's at 2.
Yep, 2. So what we're going to do is set that denominator equal to 0, right? If you're unsure, right, so maybe you can mentally kind of see, okay, 2 is going to be a problem, okay? But it's not a bad idea to set the denominator equal to 0, solve, right? Square root both sides here, and you get x equals not just 2 though, plus or minus 2 because we are taking the square root, right, in an equation setting. So both positive 2 and negative 2 are going to cause us issues. Okay, and so I'll go ahead and list that domain. Don't forget the middle interval there, the negative 2 to 2, and the 2 to infinity. Okay, so very straightforward. All right, those two domain restrictions then, the positive 2 and the negative 2, we have to determine, are they vertical asymptotes or are they wholes? Remember, if it's a vertical asymptote, it will make our function undefined. That is, we'll have a non-zero number in the numerator and 0 in the denominator. Okay? So for either positive 2 or negative 2, right, if we plug those in, all right, are we going to get 0 in the numerator? If we plug in positive 2 or negative 2, are we going to get 0 in the numerator? No, we are not. Okay? But both we know give us 0 in the denominator. So since that would be then undefined, so then both at positive 2 and at negative 2, we're going to have vertical asymptotes. Okay, so x equals 2, x equals negative 2. Okay, which means, and we've now we've classified all of our domain restrictions, so there's none left for us to indicate as a whole, and so there are no holes. Okay, so for holes, we'll say none, or you can just leave it blank, I guess, kind of thing, whatever you like. All right, now look for zeros. So zeros, right, that's when, how do we find zeros for a function? What do we do? Set it equal to 0. Okay, and of course a fraction, in this case we have a fraction, right? A fraction only equals 0 when what part of it equals 0? The numerator, when it equals 0. And so then we get x equals 0. Oops, off the screen. There we go. Bless you. So correct. So we have the point 0, 0 is a 0. All right. Last little necessary piece here, okay, to find before we graph is the horizontal asymptote. Okay, and how do we find the horizontal asymptote for a function? What do we got to do? No? Yes, Ethan, you were going to say the same thing. Yeah. Find the limit as x approaches infinity. Okay, also negative infinity, but in this case, it's going to be the same thing. So, limit as x approaches infinity of f. Okay, what will that be in this case? 3, right? So the degree of the top is 2. The degree of the bottom is also 2. So it's the ratio of those lead coefficients, 3 over 1, or just 3. Okay? It'll be the same thing for the limit as x approaches negative infinity. I'm not going to write it out. Okay, so we'll just leave it at that. So y equals 3 then is the equation for a horizontal asymptote. All right? Now let's put these pieces down and see if we need any additional points. Okay, see if we need to come up with any more points here. All right? So I have a y, let's see, horizontal asymptote at 3, a 0 at 0, and then vertical asymptotes at 2 and negative 2. So I could probably focus more on like the first 2 quadrants there because it's going to be, you know, that, but we'll see. So I'm just going to kind of sketch this out. Ooh. And put in, again, these pieces, right? So we have a 0 at 0, so I'm going to put a little point there at 0, 0. Oops, I'm off the screen. Sorry, let me do this. There we go. 0, 0. Okay. Vertical asymptote at positive 2. Vertical asymptote at negative 2. Okay. I labeled my vertical asymptotes. You don't have to. The reason why I do it is because on the benchmarks in the past, now they may have changed it, right? Benchmarks do change time to time. But in the past, I know the benchmark has always asked, because we do have a benchmark in this class at the end of the class. In the past, the benchmark has asked a question like this, and they ask you to label them. And so I just do that here as just a good practice, just so you know, all right? Because you can lose points if you don't do it on the benchmark. On our test, if the directions don't specify, label your vertical asymptotes or anything like that, you don't need to. You can just draw them in. That's fine, okay? But if it does say label them, you need to do that. Oftentimes, that means there's points attached to it and stuff. Bless you. All right, y equals 3 is our horizontal asymptote. I'm going to draw that in here. Ugh, that didn't do a very good job there, but oh well. It's a very straight line if you look at it crooked, okay? So there we are. Yeah, all right. H-A-Y equals 3. Okay, so interesting here. All right, interesting. We only have really one point here to guide us, and that's it. And it's not super helpful either because horizontal asymptotes could be crossed. So we could kind of like go up and then down, or start from the down and then go up, or we could do like this or this. So it's like kind of inconclusive. We might need to come up with some more points here. So I'm going to go ahead and do that. All right. I'm actually going to start picking a point here to the left of our vertical asymptote, just to kind of figure out whether I'm above or below or whatever here. So I'm going to pick negative 3. I like to pick something that's close to the vertical asymptote because if you go too far from that, the numbers can get like out of hand a little bit. So we'll try the negative 3 there and see what happens. But sometimes that's a bad choice too. Okay, so f of negative 3, there we go. Plug that in. Let's see here. We'll get negative 3 squared is 9 times 3 is 27 over negative 3 squared is 9 minus 4 is 5. So 27 fifths, okay, which is 5 and 2/5, if that helps, or 5.4, kind of thing. So let's see here. So negative 3, 1, 2, 3, 4, 5, and a little bit more. So right there, maybe we'll say. Okay. Good morning, Mr. Goff.
Good morning. And then just straight up notes.
Okay, and then just straight up notes. Gotcha.
I guess before this.
Gotcha. Are you going to use this as classwork somewhat then, and then homework? Gotcha. Okay.
Except for the last part, the last section.
Okay.
Equations of lines.
Right. Don't do those.
Graphs and points.
Skip these parts and the 2 points. Okay. Okay. So we got that point. We're going to do another one here. So I'm going to pick some in here as well, just to kind of give us an idea. So probably like x equals negative 1, and then probably x equals 1, too, just to kind of get an idea of the shape of the graph between the two asymptotes here, too. So f of negative 1, let's see here, it'll be squared. So it's 3 over, and then negative 3, so negative 1. That's nice. It worked out to be like decent numbers. Oops, and then positive 1. We'll try that. So let's see here. We get 3 over negative 3 again. So again, negative 1. So okay, we have negative 1, and 1, negative 1 as well. Okay, so we kind of get an idea of the shape there maybe. And then one more, I'll do f of 3 as well, just to figure out what's happening here, above or below kind of deal. Okay, so then it'll be the same thing though as the f of negative 3 because we're squaring everything here. But anyway, so 3 squared, 9 times 3 is 27, 3 squared is 9, minus 4 is 5, so yeah, 27 fifths again. Or 5 and 2 fifths, or 5.4. 3.
So it
3,
looks like a
4,
problem
5.
in the middle.
It does, exactly right.
And then I think you should do negative 4 and 4 to see if it's I think it's like the rational curve.
Exactly. It is exactly that, yes. We'll come down through the points there. If you want to, you can. I mean, yeah, if you're unsure, if you're looking at it.
So that's 4 minus 3.
Okay. But that's the idea there, okay? Of course, please don't make it look like you're going to be crossing those vertical asymptotes, right? They should not be crossed. But there it is, something like that. Okay? It's a little bit funkier than what we're used to, right? But that's the idea. All right.
That's 144 over.
Questions on this one?
It's just a tad
All right.
under 1.
Let's move on here then to slant asymptotes. Okay. Okay, and review those. All right, so does anyone remember, how do you know if your rational function is going to have a slant asymptote? Say it again there, Jenna.
Am I right?
And are you right? I want to hear what you have to say. It was kind of like 1 degree, what would you say?
I was like, I remember something from algebra 2. It was like if degree in the numerator was like 1 degree higher than the denominator.
Yes, exactly right. When the degree of the numerator. Who's your algebra 2 teacher? Mr. Walker. Ooh. I'll tell him that he reached 1 student today.
Yeah, he's not gonna care for me.
He won't care. I'll say, oh, her.
Yes, he will.
I'll say, oh, who? Anyway. Just kidding.
Has anyone in my algebra?
Okay? But yes, that is right. The numerator, if it's 1 degree greater than the denominator, okay, we have a slant asymptote. Which means if we have a slant asymptote, will it be possible to have a horizontal asymptote as well? Okay? So in order to have a horizontal asymptote, the degree of the top and the bottom have to be either the same or the bottom's degree has to be greater, right? But for a slant asymptote to occur, the numerator must be 1 greater, okay? The end behavior of the function is still going to go to infinity or negative infinity. So don't get me wrong there, right? If you take the limit as x approaches infinity of the function for a slant asymptote, the end behavior will still go off to infinity. And you'll see an example when we get to a problem and stuff like that. Same thing, if you go off to negative infinity, as x goes to negative infinity, the behavior will go to negative infinity. Or, well, sorry, I shouldn't say positive. It's going to be positive or negative infinity depending on the situation, I should say. But the idea is the end behavior will still be does not exist, right? The limit will not exist. It does go off to infinity, but we still can like kind of come up with a slant asymptote, and to help us, you know, again, draw the function and stuff. Okay, so let's just do. Well, I'll do one, and then I'll have you guys try one. Okay, so just to make sure we're okay with this, so we're going to identify the slant asymptote. Okay, of the function. So like I said, I'll do one, you do one. Okay? So we've got f of x equals x squared plus 1 over x minus 1. Okay? Now you'll notice all we reviewed was whether one exists. We didn't come up with a way to find it, but I'm going to show you that here in just a second. Okay? First of all, does this function have a slant asymptote? Yes. I mean, it would kind of be silly for me to, you know, say find the slant asymptote and then give you one that doesn't have a slant asymptote, but I guess that's something that I could do. All right. So yes, it does. Okay. Now, does anyone remember how to find the slant asymptote? Long division or synthetic division? Yep. Long division or synthetic division. Your choice. In this case, do we have to use long division? No, you can use synthetic. So I'm going to use synthetic here. So what number goes in the box if I'm going to use synthetic division? A 1, right. It's the 0, remember. Don't put a negative 1 in there. And then what numbers are going to go across the top here? Ah, good job. I didn't trick anybody, or at least that I heard. But maybe you like mentally didn't say it. You're like, whew, I didn't say it. Thank goodness. That would have been embarrassing. But anyway, all right. So yeah, there's a placeholder. Okay, there's no x. All right. So we drop the 1 down. Hello.
And then 0, 1, 1 for the second one, right?
Hang on. Let me finish this one. Drop down the 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. 1 and 0. Okay. Wait a minute.
That's 2.
It is 2. I meant to do that. Thank you. Okay, 2. My apologies there. Yes. So, sorry about that. Anyway, my point, the important information comes from this right here. We kind of throw out the remainder. We ignore it. Okay, it doesn't matter. What we look at, though, is what's the answer coefficients here. So we interpret this as 1x plus 1, right? 1x plus 1. That is the equation for the slant asymptote. So y equals 1x plus 1. Okay? It kind of looks like, well, if you don't get it, Jeff, you can use long division if you prefer. Okay? That's true. That's fine. It's just a quicker way to do it, that's all. All right, so here's one for y'all to try. All right, so let's see here. F of x equals 2x squared minus 5x plus 7 over x minus 2.
So it's x plus 1 is the...
X, well, yeah, 1x plus 1 or x plus 1 is fine. Yep. Mm-hmm. Let's go ahead there and try that one real quick, and then we'll actually do an example with slant asymptotes. Sorry? We throw out the remainder. It's not necessary for finding the slant asymptote. We just throw it out. Yep.
So the slant asymptote is x plus 1.
For the first one, yes. All right, like 30 more seconds here, 30 more seconds, and then we'll go over it. Let's try and get her done there in 30 more seconds.
Read the problem or do it in 30 seconds.
There you go, Jeff. Extreme close-up for you.
Okay, thank you.
You're welcome. Oh, that's true. You use long division. That was important.
It's not important. Dang.
Serious there. Serious, is that gonna work?
Serious. Well, I like to serious now.
It's very serious. Okay, my
Other
bad.
than when I think I'm gonna fail, then I'll scream it. Then it will be serious. When I quietly call your name, then you know it's serious because everyone's just
Of course.
Okay, what's our slant asymptote here? 2x minus 1. That's right. Anyone need to see that done?
I'm still working out the long division.
Okay.
That's 2x. I did get the first part.
So yeah, if we did do long division here, you put a 2x. And your leftover is that, so minus 1. Okay, remainder should be 5. We throw it out. Yep, there it is. Okay. All right, so let's actually do one with a slant asymptote then, right? And this will just be the one that we do for some practice here. Okay, so we're going to graph x squared minus x plus 1. Okay, and I think I'm going to try and squeeze it in here. All over x minus 1. Okay? So I'm going to have you guys go ahead here, find the domain. Okay? Identify any vertical asymptotes. Identify any holes. Okay? Identify any zeros. Interesting. And then for number 5 now, because we either have horizontal asymptotes or slant asymptotes now, for number 5, I'm going to put that as like kind of now a horizontal asymptote / slant asymptote step. So we're going to do either one, right? That's where we'll identify it there. But again, this organization doesn't matter to me. As long as you do it, I don't care what order you do it in. But I just find this order is good.
Numerator 2 or 7?
For here?
Yeah. Wait, no, not.
Oh, here.
Wasn't it 2x squared minus 5x plus something? 7.
Yeah, plus 7. Yes, in the first one. Yes.
So then that means that it would be 2x plus 1 and leave the remainder.
Yes, you throw the remainder out. It should be 2x minus 1. It should be 2x minus 1. All right, and then go ahead and find any additional points you feel like you might need, okay? So do as much of this as you can right now. Okay?
just.
Okay, and that's fine. If you want to use that every time, that's your choice. You can do that.
Yeah, but I need to learn synthetic division because it leaves less room for calculation mistakes.
True, and it's like it kind of like cuts a lot of the fat out that you don't have to do and stuff like that. I mean, so.
But I make mistakes when I try long division, and I just don't get synthetic division at all. So
Right.
This isn't helping.
And I get it, because synthetic division is just like something you just have to kind of memorize. I mean, it's not like here's how it works kind of thing. We never really go into that. So, but in this case, right, we're doing the division here, so we take the 0 of this, which would be positive 2. Okay, and then you put your coefficients. Whoops. Okay, leave some space because you're going to write numbers down in here. Okay.
And drop the 2 down.
Right, drop the 2 down, and you do 2
Divided by 2. That's
times 2.
Dang it.
So 2 times
That's
2.
what I was doing wrong.
Yeah. So what's 2 times 2?
4.
4. And then we'll add. Because and you can think about it, we added here too. It's 2 plus 0, so it's just 2. Add these, -1. And now what should I do with this?
Multiply it by -2. So that's
Multiply it by the 2.
Yeah, 2.
So we get
-2.
-2, and then add
5.
5. Okay? This is our remainder. We can throw it out for the slant asymptote calculation. We start with the quadratic, and when we divide them, we end up with a degree less. So there's your 2x minus 1. Okay? That's all there is to it. All right. Why don't you try it for this one here and see if you get the same answer.
I'll try.
Okay?
What's that one?
X squared minus x plus 1.
X squared minus x plus 1. Let's start a new page. X squared minus x plus 1.
Over x minus 1. Okay? All right. So go ahead and figure it out. I have it posted up here on the screen for you when you're done. All right, folks, here are the answers that I got. All right? Domain, -infinity to 1, 1 to infinity. Vertical asymptote at x equals 1. That domain restriction is a vertical asymptote. Therefore, there are no holes. Okay? Yellow. Hi. He is no longer. Approximately 15, 20 minutes ago. I do not. Oh, I gotcha. Yeah, I'm not sure. Yeah.
So for
Back.
this one, it's just x, right?
We just have
Slant asymptote is just x?
Yes, just x, exactly right.
Okay, I got that one right. That one's simple.
Good. All right, so zeros, there are none, okay? That's imaginary. So what we're going to do then is just graph the horizontal and vertical asymptotes here, okay? So at x equals +1, okay, a vertical asymptote, okay? And then at y equals x, oh goodness, try and get this here somewhat. 4, 4, 5, 5, yeah. Mine are always, so I don't know why you have a problem with that.
straight.
Perfectly straight. I don't even need a ruler.
Nope.
Okay.
Didn't even hit that last one.
It's all that practice that I've been doing on my Friday nights.
Oof.
Okay. Sometimes we'll have Mr. Goff come over and we'll just practice our slant asymptotes and vertical asymptotes together.
That sounds like an exciting party.
Wasn't what you guys do on Friday nights?
Yeah, sounds about right.
So that's what I thought. It's normal Friday night stuff.
Friday night,
So, okay, we have kind of an idea about what our graph should be, but here's the problem. Again, we kind of have 4 quadrants, 4 little sectors here we've created, okay? So our graph could be in here, but it could be here. It could be in here, but it could also be in here. So we need to judge that, and that's going to be done by picking points. I'm going to pick f of 2. F of 2, if you do the math, gives you 3. Okay? I'm going to pick f of 0 as well, because 0, even though it's on the slant asymptote, you can pick a point on the slant asymptote here. It's more the, or an x value that's, it might not be on the slant asymptote. I'm going to pick the x coordinate of 0. It could be above or below here. That's fine. As long as it's not on that vertical asymptote. You don't want to plug in that. So I plug in 0, and I get 1 over -1, which is just -1. Okay? So plotting these points, 2, 1, 2, 3. Okay, and then 0, -1. And that's all we really need. At this point, we can say, aha, we're going to be in this little section here. So I'll just kind of like hit that point and then like curve right back around and follow that slant asymptote up. Yeah, it is. And if you want to put in your graphing calculator, you can see it too. I mean, this is what it's going to look like, something like this. And then voila.
I've never seen a graph like that.
Yeah, and make sure you put parentheses around the numerator and denominator when you do it. Okay, there it is. There it is.
It looks like a really complicated traffic.
It does. Yes, it does. Okay.
Looks like a really complicated what?
Traffic kind of intersection or something, yeah.
To me, it looks like
Okay, so
an hourglass.